Welcome back. This is Mr. Hassan's Maths channel, and this is the final question on this January 2024 Pure Mathematics P1 International A-Level Edexcel exam. This is question number 10, and we are told about a curve C which has equation y equals f of x, where x is greater than 0. And we're told 3 bits of information about this curve. Firstly, that the point P, 2 for the x coordinate and 8 root 2 for the y coordinate, lies on C. So this point is somewhere on this curve. And we're also told that f dash of x is equal to 4 times the square root of x cubed plus k over x squared, where k is a constant. So f dash of x is another way of saying dy dx. Okay, it's another way of saying dy dx, meaning the first differential, the gradient function. And f double dash x equals 0 at P. So at the same point P, this point here, at that point, the gradient, or the gradient of the gradient, the second differential, is equal to 0. Second differential is like d squared y dx squared. There's just different ways of saying that. So we've got to find the exact value of k using this information. So basically what we can see here is at P, we have 2 things that we know about P. We know that x is equal to 2, and we also know that f double dash x, the second differential, is equal to 0. So using that information, I'm sure we can find the value of k. So the first thing we need to do is find f double dash of x. So let's take f dash of x, which we have, and rewrite that in a way which is conducive for us to differentiate it, because to go from here to here, we differentiate. Okay, so what we can do is we can rewrite this. We have 4 times the square root of x cubed. Now we can use the law of indices if we consider the square root of x cubed. Okay, and the law that we can use is basically this law here, that when you have the m root of a to the power of n, you can write that in index form, where you have this number here, the power is the numerator, so it's a to the power of n over m, and this is the denominator, the root is the denominator. So in this case, you have 4 times, and you're going to have x to the power of, now 3 is the power, so that's going to be the numerator, and 2, it's not written here, but there's a 2 there, which is the denominator, which is going to be 3 over 2. 4 times x to the power of 3 over 2. That's how you write this in index form. And k over x squared, well, we know that 1 over x to the power of n is the same as x to the power of negative n. So we can say this is going to be plus k times x to the power of negative 2. Right, that's f dash of x. Now it's ready for us to differentiate. To differentiate this, we have to multiply by the power. So we have 3 over 2 times 4, which is going to be 3 over 3 times 2, which is 6. Because if you have 3 over 2 times 4, they cancel. So 3 times 2 is 6. Take 1 from the power, that's going to be to the power of a half. 3 over 2 minus 1, which is 3 over 2 minus 2 over 2, which is a half. And then minus 2 times k minus 2k, x to the power of, take 1 from the power, that's negative 3. Be careful there. You know, a lot of people put it as a minus 1 by mistake. No, it's negative 3. Take 1 away from minus 2, gives you negative 3. And now we can rewrite this. Let's rewrite this in a way that's easy for us to substitute values in. So I'm going to write this as 6 times the square root of x minus 2k over x cubed. Just rewriting it in a way that's easy for us to substitute values into. So we know that at P, as we mentioned, x equals 2 and f double dash x is equal to 0. So if I replace the x with 2, I have 6 times root 2 minus 2k over 2 cubed, and we know that's going to equal 0. So we can say that 6 root 2 is equal to 2k over 8, just squaring the 2 cubed, and 6 eighths are 48. If you multiply both sides by 8, so 6 eighths are 48, so 48 times root 2 is equal to 2k. So therefore, dividing both sides by 2, you have 24 root 2 equals k. So therefore, k is equal to 24 times the square root of 2. Okay, so there's the answer to this question. So we found the value of k. Okay, and that's part A, 4 marks for that. And now for part B, it says find f of x, giving your answer in simplest form. So we know that k is equal to 24 root 2. So we have 4 f dash of x. Now we can write as 4 times the square root of x cubed plus 24 root 2 over x squared. Okay, so again we can write this in terms of something that's easy for us to deal with. This is 4, as we mentioned before, x to the power of 3 over 2 plus 24 times root 2 times x to the power of negative 2. So this is f dash of x. Now we want to go from f dash of x to f of x. Okay, so here we have to integrate. Remember, we have f of x. If you differentiate that, you get f dash of x. If you differentiate that, you get f double dash of x. If you want to go this way, you have to differentiate. And that's what we did. We went from there to there. Last question. But if you want to go this way, we have to integrate. So if you want to go from f dash of x to f of x, we have to integrate this. So we can say f of x is equal to the integral of f 4x to the power of 3 over 2 plus 24 times root 2 x to the power of negative 2 with respect to x. And we got to find what f of x is. So first of all, we integrate. There's a couple of ways we can do this, but I'll stick to this particular way because we don't learn about what's called integration, definite integration until P2, so I'll leave that for later. The other way that I was going to mention, but no problem. So here we're going to integrate each term separately. So we have to add 1 to the power and divide by the power. Integration involves adding 1 to the power and dividing by 1 by the power. So you get 4x to the power of, if you add 1 to 3 over 2, you get 5 over 2. Then you have to divide by 5 over 2. Plus, and you have 24 root 2. Add 1 to the power, you get x to the power of minus 1. Divide by the new power, which is minus 1. And don't forget, very important, the plus c. Okay, plus c. So we know this is like y equals. You can say y equals, and now we can rearrange this. So this is like when you're dividing by 5 over 2, it's like multiplying by 2 over 5. So 2/5 times 8 is going to be 8/5. So 8/5 x to the power of 5 over 2. And this is going to be minus 24 root 2 times over x, we can say. Just rewrite it in this form so it's easy for us to substitute. Over x and plus c. Now we know that the point P lies on the curve. So we can say that 8 root 2 is on the curve. 8 root 2, sorry. 8 root 2. 2 and 8 root 2 is a point on the curve. So we can say from this that when x equals 2, y equals 8 root 2. Okay, we know this information, so we can now use it in this. We can replace the x with 2 and the y with 8 root 2. So we have 8 root 2 equals 8 over 5 times, now this is like the square root of x to the power of 5, so this is going to be 2 to the power of 5, the square root of 2 to the power of 5, minus 24 times root 2 over 2. Okay, so we get plus c, of course, because that's what we're trying to find. We're trying to find what plus c is. We've almost got the equation. We just need to find what plus c is, what c is, and then we're gonna be able to find the whole equation here. So now let's try to sort this out. This is 8 root 2 equals 8 over 5. Now what we can do is we can write this as root 2 to the power of 4 times root 2. That's like root 2 to the power of 5 minus 12 root 2 plus c. Okay, so you have root 2 to the power of 4, which is going to be 2 squared. Okay, because it's like root 2 times root 2 times root 2 times root 2, which is going to be 2 squared, which is going to be 4. So we have 8 root 2 equals, that's 8 over 5 times 4 root 2 minus 12 root 2 plus c. So we can add 12 root 2 to both sides. That gives you 20 root 2 equals, that's going to be 32 over 5 root 2 plus c. So we're going to subtract 32 over 5 root 2 from both sides. So you have 20 root 2 minus 32 over 5 root 2 equals c. So C equals, that's 20 root 2. That's like 100 over 5 minus 32. 100 minus 32 is going to be 68. So 68 over 5 root 2. So I think that's the simplest it can go. So we can say that the equation for f of x therefore is going to be equal to, you can put 8 over 5 times x to the power 5 over 2, and we have here minus 24 root 2 over x, root 2 over x, and then plus 68 over 5 root 2. And that's the equation of our curve f of x. That's what they ask us to find. Give you an answer in simplest form. Okay, so I don't think it simplifies more than that. 68 over 5, that's correct. So there we have our answer for f of x, and that completes this question and this paper from the P1 of January 2024. All the other questions from this paper you can find in the playlist, which will appear at the top right screen of this video. You can click on that link to get there. Other questions dealing with differentiation and integration from P1. I'll put differentiation in this playlist and integration in this playlist. I could have saved them as separate videos, but no problem. And you can also subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.